Well, we're going to try to machine some parts. I'm not sure how many of you guys would be interested in this, but I'll show it. I'll make it fairly shortish, kind of, but some might find it semi-interesting. So we're going to go ahead and work on the main shaft first, which is the main swing arm shaft, I guess you could say. So this is the one that came out of it, and so it would be on the right side of the bike. It has this larger thread with almost a kind of a crown nut, and on the left side it has this nylock which threads on. So we're going to make one complete shaft that incorporates probably not a hex on the end, but maybe just something a little easier. This thread going down, it's going to be just under 1 inch to fit the Timbersled, because the Timbersled is a 1 inch bore on that hook up there. So it's going to come this size here down, step down to 1 inch the whole way across the full 1 inch, and then right where that black mark is, it's got to step down back to this dimension. And that dimension there is in millimeters because it's European, which is 20 mils right on the dot. 20 mils right on the dot. So I got to get a couple dimensions off the bike for a quick second, but we're going to be using a piece of chromoly shaft. It's also known as 4140 or 4000 series. I'm going to drill a hole through it. I do have a gun drill laying around. I can just gun drill it. I do believe that's, I don't know, probably looks to be maybe a 1/2 inch hole or something like that. 12.8, so that's almost, well, just a little over 1/2 inch. So if I can find a drill, I'm gonna make it hollow too, because it'll save a little bit on weight, and there's no need to have it that heavy. So the machine we're using is this DMG NEF 600. I've had this now for probably, I don't know, 10 years or so. It's a pretty decent machine. Mechanically, it's really good. Electronically, it's the biggest piece of trash on planet Earth. We're gonna go ahead, swap out the jaws. We have a threader in there already, finishing tools in there already. We got a rougher. We'll need these three, and then I'll need a gun drill to drill the big hole. We'll need a center drill in here. We'll pull this thing here forward because we're gonna need that tail stock to push forward, and we can index on this hole here so that we can machine a nice long shaft in one go. Jaws are in, and now we can stick this into its place, clamp it in position, and we get a green chuck up there, which means that it's up to pressure. Unfortunately, all of the gun drills I have are too big. They're in the 5/8 range, and this is in the 1/2 inch range. Okay. Just see it take a little cut off of there. And then just manually machine this. I'm not programming this or doing anything. I'll go a little bit deeper. Alright, there's a nice chamfer. Can't complain with that. Looks pretty decent. We'll do the trick. Alright, so I couldn't find how long drill, but I know I have a bunch, but they seem to have found some legs and walked away. So we're going to take this one here, we'll drill through the half this way, machine the whole OD, and when we're done we can flip it around, and when we're facing this side and doing the profile for a tightening tool, we can come back and finish it from that way there. Looks pretty happy. Have it sticking out that far. Then we can put the tailstock in here to hold it, and then we can start machining the profile. Alright, so preliminary, it looks pretty decent. Alright, so there we got our thread. This here, just like that. And now we're just going to cut it off. Go. Alright, so steady rest is back in its original spot. We got our jaws set up, got the piece flipped around, zero's reset. We're going to run our small thread up front here. Up here. So we're still looking a little square on the threads, and this doesn't want to quite go. So we can go another. Looks like we'll do another 5 thou or something like that. There we go. Getting into the nine lock there. Call her a day. We're just going to finish this side. We're going to face it. Put a spot drill on it. Spot drill on it. Drill her nice and deep, and then this pin's pretty much done. And this is the finished result. So we have shoulder on that side, the OEM nut fits, or the OEM nylock fits quite nice, perfectly. And then we have the 1 inch, tickles the Timbersled. And we have the old OEM castle nut. And then I just did that on the end there, so I'll make my own tool to nicely slip in that so we can tighten the bolt down. Well, I'm going to keep working on her. We got the shaft done the other night, and really tonight we want to get the bushings done for it. And after we get the bushings done, we can go ahead and get that track mounted, and I can kind of measure up some ball joints for it. So the other thing we might do too is measure up the head on it to see how, or what I'm going to do with these triple clamps. I might need to swap them to a KTM set or something like that, but we'll see. That's later worries. So that's the shaft we worked on for the other day. Now I'm going to make some bushing material out of this bar here. Just a chunk of 6061, and these bushings will be pretty quick and easy. Maybe take me an hour or two, but I got a nice tip insert drill. This is 25.4, so right on an inch, so it should fit over this with a couple thou play, which will be perfect. Alright, we're just stealing a tool out of here for a lovely lathe. Sweet. We got our setup somewhat started here. Got our jaws set, got our stock clamps, we got our 1 inch drill. This is a 25.4 insert, and I have a 25.5. I need to open it up, but I want my bushings to be nice and tight. Spot drill, got my finisher. I don't really need these tools, but I gotta leave that in there. Let's make a program. Alright, so there's our hole. Take this pin, that should slide inside. That's better. Look at that. That's a much nicer fit. So I can nicely live with that. This here is going to be an RPM of 400, so there it is. That's just out of the machine. Got my hole, bit of a burr on that side, and I'll show you how we can finish this to make it look like a nice professional piece without spending too much time in the machine on it. There you got it. Bushing number 1 is done, so it's a perfectly pressed fit, and would you look at that? Gorgeous. So the frame gap is 268 in the bike. Timbersled is 184 millimeters divided by, or that's 84 divided by 2. 42 millimeters per bushing divided by 25.4. 1.654. Pretty simple. Alright, 2 bushings, pretty happy with that. If I did a good job, I should be able to push this sleeve over. Take this like that. Push it through. And when this one goes on, it should be perfectly flush with that shoulder. Oh yeah. There we go. Look at that puppy. Gorgeous. So it looks like it's like maybe 5 thou in, which I'm quite happy with, because once I tighten this nut up here, it's going to pull the frame against that, and it's going to be one big old solid assembly. Just got her fit. It looks pretty good. Pretty happy with it. Nice snug fit. There's absolutely no play in it, so pretty pleased. And she ain't definitely not going to bend that pin, that's for sure. And if you're wondering what we're using for a tool, I just took a chunk of 1/4 by 1 flat bar laser cut, or it's just a chunk of laser cut steel, but I just put it in the belt sander, sanded it round, and that fits just like that. There, that's my key. So that's that little 1/4 inch end mill, put in that little key in the end. So alright, so we just took the battery out. This bottom plastic came out, and just kind of a skeleton now, which is fine. And we're just trying to figure out this top link here. So if you look straight down on it, you can see that this top lug here is perfectly in line with this right edge of the Timbersled. So what we got to do is I might have to sand a little bit off this here, which is fine because it's got a little bit of an extrusion there. And then we're going to put another link right here, and our ball joint's going to go in there. We're just got to figure out what size this is, so we can just figure out what kind of ball joint's going to go in there. So we're going to go ahead and cut these 2 lugs off. We're going to try to reuse this lug here on the top lug. So I got a zip disc on here, which is semi-sketchy. I'll stay out of the line of fire, and I'll very carefully zing it off. I got those lugs cut off. Looks pretty good. And they're the 2 lugs. I probably won't use this one here, but this one here is exactly what I'm looking for. So I'll have to die grind this surface, get all the rough casting nice and cleaned up. I'll have to clean this all the acetone before I start to weld it, or TIG weld it, and that's going to get TIGged right there. Now the cool thing is this is a 16 millimeter hole, and I can use these 2 to run a bar through to fit this one perfectly in position. So now I'm just going to release these four subframe bolts for a second, just because I have to just get in line with those two other bolts there for a quick second. Got the little strut in there. Then tomorrow I can get my brother to TIG weld it if he feels like it. But it should work pretty good. I might take a zip disc to cut it out for a second, and yeah, it'll be dead nuts. We finished work on the back as far as we can go, taking the triple clamp off, and we're hoping to swap this with an MX style. I got my 250 over there, and we'll kind of just measure it up and see what it comes out to, but I don't think it's looking really good. So if you guys have any idea on what I can swap this with, leave a comment below, because it might help a little bit. Found a spanner wrench out of my CNC box. Just clip it on there. Alright, so we're going to go ahead and weld this lug this morning. He's going to pull the swing arm off. You want to get a side cutter to cut that, or you just want to flip it over?
It's a subframe.
What did I say?
Swing arm.
Oh. Subframe. Still sleeping. Got the whole thing hanging like this. I did empty the oil out of it just so we wouldn't get any oil up in the head or something like that. But yeah, a bit of a chore to take that on. So now we actually have it positioned correctly. We'll be able to get very pretty weld. So I did wire brush it again for you, but you might have to want to shave that nasty ass one down. Did a bunch of cleanup and just kind of ready to put things away because I'm getting a little sick of working on this thing, but we made some good progress. We got that lug is all nicely welded in there. We got a really nice fillet up on that all the way around. The inside's a little bit less to make room for the ball joint, but yeah, it worked pretty good. The only lesson I learned out of this is that I used a aluminum alignment pin, and next time I'll be using a piece of hardened steel or a steel alignment pin, just because getting that aluminum pin out was a bit of a trick after it got so hot from welding it. But it came out. We'll do a little bit of cleanup after this with a bit of a die grinder and make it all pretty. I'm not sure if I'm going to keep that one on there or if I'm going to cut it off. But I think she looks pretty good. It's not going to come off. Plenty of clearance in the fuel tank. So I'm just super happy with it. I'm going to build the back strut that's going to hold the Timbersled in place. Now normally you'd put a TSS kit or whatever, a small shock back there for a bit of extra clearance, but we don't have that choice on this sled just because the exhaust has to go there. So I got to pick up some ball joints, but I'm going to machine a little aluminum strut piece in between, and I'm actually going to be doing a 1/2-inch thread, or sorry, a 1/2-inch ball joint on one side and a 5/8 on the other side. Now might seem kind of weird now, but next week you'll understand why I'm doing that. So I just have a couple got a couple nuts here for reference, and I just took my numbers for my ball joints for a quick second. I know that my full gap from center to center has got to be 180 mils or 7.086. So I need a little strut piece that's 3.58 inches long, and I gotta account for these two nuts. So be pretty quick and easy. Won't take me very long. And that way I'm going to get out of here. Alright, program's done. Maybe takes 4 minutes to write a program. Pretty simple setup. there she is. Did the first one for you guys without coolant, and then I do a second one with coolant just because the finish is always 10 times better. So you'll see that the big nut will sit on this side, so that's where it'll lock in that way, and then the half-inch nut, the taper is slightly different for the half-inch nut, so it tapers in really nicely. So yeah, I just have to wait for my ball joints to come in, and I can I'll drill this and I'll thread this in my small little lathe on the far side of the shop there. So, well, I'm done for the day. I put this back out in the warehouse, and I got some parts here that I took off. I bagged up a bunch of small parts again. I'll be able to reuse these bushings for my top link, which I'll show you guys next week. If anybody needs a steering dampener, that'll get tossed on eBay at some point. But yeah, I did order some new triple clamps from a KTM 450, so hopefully those come in next week. I gotta get some forks figured out. If anybody has any forks, give me a holler, because I'm trying to figure out what kind of spring rate I need for this thing. It should be something heavy. So if you guys liked the video, smash that like button, and if you have any good comments or input, put them down below, because it's always helpful. And have a great week.